Okay. You are analyzing XYZ Corporation, which has just paid a dividend of 2 kwacha per share. The required rate of return for equity investors is 10% based on the different phases of the company's life cycle. Answer the following three independent scenarios. Scenario A: XYZ has matured and is expected to pay the same dividend forever, no growth rate in dividends. What is the value of the stock today under the no growth? All right. So this is the first scenario, no growth rate. Okay. You want to find out what is the value of the stock. Okay. And this is the formula here. The price of the stock is the current dividend, or the dividend that has been paid, divided by the required rate of return. The current dividend is 2 kwacha. The required rate of return is 10%, which is 0.1. So 2 divided by 0.1, that is 20 kwacha. Okay, so the value of the stock is 20. You can even use dollars, $20. Yes. Any questions on the no growth rate? Scenario B, constant growth. XYZ is in a stable growth phase with dividends expected to grow at a constant annual rate of 5% forever. What is the intrinsic value of the stock today under their constant growth? So here, when the growth is constant, the formula becomes this here. Okay. This expression here, DO multiplied by 1 plus G, that is next year's expected dividend. Okay. Let me put it like this here. D1 here. All right, D1 here. Okay, D1 just represents the expected dividend. Okay. So D1 breaks down into DO multiplied by 1 plus the growth rate divided by the required rate of return minus the growth rate. Okay, so DO, which is $2, multiplied by 1 plus 0.05. Remember, the growth rate is 5%, so it's 0.05 over the required rate, which is 10%, 0.1, minus the growth rate, which is 5%. Okay, so 2 times 1.05, that is 2.1. 0.1 minus 0.05, that is 0.05. When we divide the two values, we get $42. Okay. That is the value of the stock, $42. Yeah, this is for the constant growth rate, where the growth rate is just 1% forever. All right. Then the third and the final scenario, okay, multi-stage growth. All right. So they say XYZ is currently in a high growth phase. You project the following. Years 1 to 3, the dividends grow at 12% per year. Okay, then year 4 and beyond, growth slows down to a constant 4% per year forever. So we need to calculate the intrinsic value of the stock using the two-stage dividend growth model. So for the multi-stage growth model, step 1, calculate the expected dividends for the, in this case, for the first 3 years. Okay. These expected dividends, we're still using this formula here. Okay, this is the formula I'm using. Okay, so the dividend for year one, okay, dividend for year one, expected dividend for year one, D1 equals DO multiplied by 1 plus G. Okay, calculate the expected dividend for year one, and you put it like this. DO, that $2 which was paid, multiplied by 1 plus the growth rate. Growth rate is 12%. So 1 plus 0.12, that is 1.12. So 2 multiplied by 1.12, we get 2.24. This is the expected dividend for year one. Okay. Then next you get the expected dividend for year two, which is going to be D1 multiplied by 1 plus G. Okay, so D1 is this 2.24 multiplied by the growth factor 1.12, you get 2.5088. Yeah, that's expected dividend for year two. Then expected dividend for year three, it is D2 multiplied by 1 plus the growth factor. So that's 2.5088 multiplied by 1.12. You're going to get 2.809. Colleagues, any questions with step one, where you calculate the expected dividends? Okay. So step two and step three can be combined. Okay. They can be combined into one step, but let me just put them easily as, let me break them down into separate steps. But the more you do these questions, step two and step three, you can just combine them. So step two, calculate the dividend at year four, the start of the constant growth rate. Okay, because remember, after 3 years, the dividend is going to start growing at a constant rate of 4%. Okay, so D4 equals D3 multiplied by 1 plus the growth rate, the constant growth rate, which is 4%. Okay, the constant growth rate is 4%, and 1 plus 0.04 gives you 1.04. Okay, so the dividend for year four is going to be equal to D3, which is 2.809856, multiplied by the growth factor of 1.04, and you get 2.922. Okay, this is the dividend for year four. Okay, when the growth rate is constant. Now remember, colleagues, since this dividend, since the growth is going to be at 4% forever, okay, and it's going to be a big job to start calculating the dividend for year 5, 6, 7, 8, 9, 10. You don't know where forever ends. Okay, so it's going to be a big job calculating all these dividends after year four. That's where we bring in this terminal value. This terminal value is representing all the dividends after year four. I mean, starting from year four onwards. Okay, the value of all those dividends from year four onwards. Okay, so this terminal value, okay, it's the same as it's the same formula we're using for the constant growth phase. This one here. Okay, it's this same formula that we're using for the terminal value. Okay, so for the terminal value, okay, this is applied at the end of year three. Okay, this terminal value is represented at the end of year 3, before the growth starts. Okay, so the terminal value, TV, for year 3 is the expected dividend for year 4 over the required rate of return minus the growth rate, the constant growth rate. The dividend for year 4, 2.922, required rate 10%, 0.1, minus the growth rate 0.04, which gives us 0.06. So we say 2.9222 divided by 0.06, get $48.70 quat. Okay. Yes. So as I said earlier on, you can combine step 3 with step 2. Okay, because here, when calculating the terminal value, D4 is the same as this. Um, yes. Now, once I've calculated the expected dividends for year 1 to year 3 and the terminal value, which applies from year 4 going onwards, you are going to discount this into today's value. You're going to get the present value of all this money in the future. Okay, this terminal value, we're getting its present value. These expected dividends, we're getting their present values. Okay, so if you remember, colleagues, present value equals future value over 1 plus r to the power t. Okay, present value equals future value over 1 plus r the power t. Okay, this is the formula we're using. So have you seen for year 1, the expected dividend for year 1 over, remember the discount rate is going to be the required rate of return. That's what you're going to use as the discount rate. Okay, do not apply any growth rate as the discount rate. The required rate of return is 10%. So for year 1, the dividend for year 1, okay, it's discounted to 1 year. That's what I've put here to the power 1. The dividend for year 2, in the denominator, as you can see here, to the power 2. Then the dividend for year 3 and the terminal value, okay, they're all going to be discounted to the power 3. Because remember, the terminal value is being applied at the end of year 3. Okay, that's why we're discounting it 3 years backwards. We're not discounting it 4 years backwards. No, 3 years backwards, because this terminal value is applied at the end of year 3. So once you add these two, you get 51.51. Okay, these denominators, we've already solved them, and you just do your divisions. 2.2 divided by 1.1, 2.03. 2.58 divided by 1.21, 2.07. 51.5 divided by 1.331, 38.7. You add these together and you get a present value of $42.81. Okay, since money is in 2 decimal places, for $42.81. That is the value of the dividend today, using the multiple growth stage model.